Okay, so first we'll be going over the ECM blower motor. And you know it's an ECM blower motor because it has this big motor module on the back, and you will not see a run capacitor in with the motor. Okay, so once we have killed power to the unit, we double check with our multimeter that there is in fact no power to the unit. We can remove our blower assembly. It's just usually a couple screws. We can pull it out. Then this is what the motor module is going to look like on the unit. There's going to be two 1/4 inch drive screws here, so you just need a 1/4 inch chuck driver. We remove these two screws and then we carefully pull this back. It's always good to let it sit for a few minutes. That way everything has time to calm down and you don't get shocked. So there's a plug on the inside here, and then there's a plug on the inside here on the actual motor. So you have to stick your finger in there carefully and pull this little tab back on the side here and release the module from the actual motor. Okay. Now these motors are actually, even though they're in a single phase unit, they're actually wrapped on the inside to make them into 3 phases. Okay, that's how we got rid of the capacitor. Any 3-phase equipment you see, your 3-phase motors don't have a run capacitor. And when we switched to 14 SEER, we had to get rid of the run capacitor to achieve true 14 SEER across the cabinet. So first thing that I always like to tell guys is do your visual inspections first. Look at your capacitors. These here are actually capacitors for the motor module. Sometimes you'll see them split, busted open, and a bunch of ooze and stuff coming out. You obviously know that's where your problem lies. Also, inside of this motor here, I don't know if you can see, but there's a little black guy right there. All right. You see that little black circle, half circle right there? That's called a current limiter. 9 times out of 10, that's the problem in these, if it's not the capacitor. And you could actually buy these and keep them on your truck and solder them back in there, but most people don't do it. And you know, if the unit's under warranty, a couple things just to keep in mind is if the module's bad and the motor's good, you can change just the module. But a lot of times if they're going to warranty both, then you might as well change both. But you know, that's a little bit more labor cost on the customer, so you just got to keep that in mind and give them those details. All right, so let's dive in. We're going to set our multimeter to ohms, the little horseshoe setting here. All right, and we're going to ohm out the module first. Now since this is a 3-phase motor, all 3 of our resistance readings should be equal to one another. So we're going to call these pins 1, 2, and 3. Okay, so we'll write it down so you can see a little bit better. So we got pins 1, 2, and 3. So first we're going to check between pins 1 and 2, and then pins 1 and 3, and then pins 2 and 3. And since it's 3-phase, we should have an equal resistance reading on all 3 of them. Just scoot this over a little so you can see there. So first we're going to check between pins 1 and 2 and make sure you get a good, you know, a good connection on there. You really got to press down sometimes. If you're not reading good, make sure that your probes are pressed down, make sure they're pushed all the way in. So we have a resistance value of 5.5 between 1 and 2, 5.5. Now we're going to check between 1 and 3. Again, we have a resistance of 5.5. And then between pins 2 and 3, finally, and we have a resistance value. This is 5.6 at the moment, but it'll drop a little, and it's okay to be a few points off. We just don't want nothing crazy. So again, we have another 5.5. So this module is good. All right, now we're going to look at the actual motor itself. So on the plug, we have the same concept. We have pins 1, 2, and 3 on the plug. All right, so up here is the module, and down here's the plug. So again, we'll check between pins 1 and 2. Make sure you got a good reading on there. Make sure you're pressed good. So if you can see on the meter there, we have a resistance value of 9.9 or 10, 9.9 right there. All right, so between 1 and 2, we got 9.9. Between pins 1 and 3, same thing, we have 9.9 to 10. Right there, 9.9. So 9.9. And then between pins, finally 2 and 3. Again, 9.9. Sometimes it takes a minute to get up there. You just have to be patient, but there it is, 9.9. So in this case, our motor and our module are both good. All right. So that's how you test an ECM or a 3-phase motor. It works the same on anything 3-phase, like a mini split compressor. That's actually a 3-phase compressor, so all 3 resistance values will be the same between run, start, and common. But on a scroll compressor or a PSC blower motor or outdoor motor, it's going to be a little bit different. So that one right there is an ECM. All right. Now we're going to do the PSC, which is a permanent split capacitor. All right, you're going to have a couple different wires on these. You're usually going to have 2 wires that are designated for your run capacitor, which are my solid brown and my brown and white. This is just a rescue motor, okay? So our capacitor goes in series with those 2 wires. We'll stick them out the way. Next, you'll have 2 jumper wires like this, and they're usually going to be 2 different colors, black and white, yellow, orange, whatever. These are just the rotation of your actual motor. So on this one, it tells us if we do yellow and orange, we'll go counterclockwise. All right, if we do yellow and then orange and orange, we'll go counterclockwise. So it's opposite, clockwise and counterclockwise. You just switch them. All right, and then we have our other 3 actual power wires here. All right, so we're going to take resistance. We're going to picture these as a plug the same way. We're going to do between 1 and 2, 1 and 3, and 2 and 3. Now, on any PSC or single phase motors or single phase compressors, our 2 lowest resistance values are going to equal our highest resistance values. So hopefully you can see the meter there. If not, I will write them down. So we'll do between red and black. We'll do between red and white. And then finally, black and white. All right. Careful not to touch your actual fingers to the leads, because you will pick up resistance of your hands, of your body. We are electrical beings, so just keep that in mind. You want to make sure you have a good connection there. So first we're going to do between red and black. Sorry about that. So we're going to put that guy there. We're going to do red and black. All right, red and black, we have a resistance value of 7.9. We'll call it 8. We have a resistance of 8. So 8.0. Now we're going to do between the red and the white. It's a little bit easier when you got spade connectors on here. You could shove your meter into. And here we have a resistance reading of 26. I'll call it 26. We won't do the extra little decimal point, just to make it easy. All right, and finally we got black and white. We have a resistance of 18. All right, so if we add 18 plus 8, we're going to get that 26. So then we know it's a good motor. That is how you test permanent split capacitors versus electronic control modules. All right, guys, we'll see you on the next one.